spam. You should import the required library pandas and the class string from NLTK corpus. Import stop words that you have to install as part of the environment setup. Next, get the spam data collection with the help of the pandas library. Here, the /t indicates the data in the spam dataset is tab separated or tab delimited, and SCP function takes it as a parameter. Also, message is the text present in the dataset, which is a feature. Response is the label or the category of the message. Now, view the first 5 records of the spam collection. The .head method is used to view the topmost records in a dataset. To view more information about the spam data, use the describe function. It will provide the desired output with the response and message for count, unique, top, and frequency. This basically is the statistical summary of the dataset. This is a good way to learn more about data. To view the spam collection according to responses, apply the describe method and execute the group by function on response column. The collection displays a list of messages. To verify the length of the messages, pass length as an argument inside the parentheses. This is a basic pandas operation syntax to add columns to pandas data frame. To check the earlier passed argument on length, let's view the first 5 messages with length. It will display the responses, message, and length of the spam collection. Let's define a function to remove the stop words from the messages. Create a user-defined function to eliminate the stop words. Stop words usually have little lexical content. In other words, less meaningful words when it comes to text analysis. Some examples of stop words are I, me, myself, we, our, ours, you, yours, etc. First, use the string class punctuation to remove all the punctuations present in each message. Punctuations are also less weighted for text analysis. Then, we remove the stop words. Verify that the function is working by applying the custom function message text process, and then view the first 5 messages with the .head method. Next, start text processing with Vectorizer. Use the Count Vectorizer class to convert the collection of text documents to a matrix of tokens. This assigns numeric value to each word present in the text. This class is imported from Feature Extraction Text Library of sllearn. Try to convert the text to a numerical feature vector by using the technique bag of words. Use bag of words by applying the function and fit the message into it. We do this by creating an object bag of words and then vectorize or assign numeric values to them by fitting the message data using the fit method. Now that you have used bag of words, print the length of bag of words stored in the vocabulary attribute. Then, store bag of words for messages using the transform method. Apply TF-IDF transformer and fit the transformed bag of words in it. TF means term frequency, while TF-IDF means term frequency times inverse document frequency. This is a common term weighing scheme in information retrieval. First, we fit the bag of words into the transformer using the TF-IDF transformer instance, and then we use the transform method. It actually transforms a count matrix into a TF or TF-IDF representation. Print the transformer shape. To detect spam, we will also use the naive Bayes method and fit the transformer data into it. Naive Bayes is one of the most statistical procedures or models to classify the texts. Once you fit the transformed TF-IDF message or bag of words and response into the model, we can go ahead and try to predict the response for the given message. First, get the second message by passing the index position for the message, and then transform that message as bag of words using the transform function. Then, again, perform the TF-IDF transformation using the TF-IDF transform function. Now, try to predict the response using the predict method of the model, and then check the actual value present for the second message in the dataset. As you can see, the predicted value matches the actual value. So this proves that the text processing algorithm and the model are working properly. Repeat the process for message 5.